So accelerometers are useful to figure out what animals are doing when you're not there to check up on them. So we're using an Arduino-based microprocessor. They're only about 20 by 20 millimeters big, called a TinyDuino. So first of all, we have a processor, and as you can see, it's quite tiny. So it's got a charging port, it's got an on-off button, and it's got a connector section for the other processing boards that we're using. And we also have an accelerometer of the same size, which is a 3-axis accelerometer. And it also measures temperature. We also need an SD reader so that we can log our data somewhere, and an SD card that will contain the data. And finally, we also have a battery. And extra things that you need is a micro USB cable, and you also need a computer to get this to work. And we have a USB shield now. We only need one of these, and we can set up multiple units with it because this one's used to communicate between the computer and the TinyDuino and upload the scripts. So first of all, we put it together. If you look at the back of the processor, it doesn't have that little bottom area. So it needs to be at the bottom, and we put on the accelerometer. Okay, there we go. And then we put on the SD reader, and then we want to put the USB shield on the top because we'll remove it afterwards for deployment. And then we put in the SD card. Here we go, and plug in the battery. There we go. And then we take the micro USB cable and we connect it to the USB shield, and then the other USB port can go into the computer. So when you plug this in, this little light should come up, and it's telling you that the battery is charging on for the TinyDuino. So orange light for charging. Now I'm using a Mac, but it works pretty much the same way on a Windows. So first of all, go online, and what we want is to download the Arduino IDE, which is used for uploading scripts. So just find that online, download it, and install the way you would normally install a software. Here we go. And then once it's installed, when you open it, you get this window up, which is a basic sketch window, but with nothing in it at the minute. So before we start, we need to actually set up the computer to make sure that it recognizes the board. So we're going to Tools, the Board, and it needs to go to Arduino Pro and or Pro Mini. And then we need an Mega 328p, 3.3 volt, 8 megahertz is the board that we're using. And finally, we make sure that the port is correct. So on the Mac, it should be set to the USB serial, so the bottom one. Here we go. And now, first, let's make sure it's working. So let's use an example sketch. So we're going to Examples, go into Basics, and press on a sketch called Blink. And it should open a code file. There we go. Have a look. You see there's a code there. The way to upload this on an Arduino is to simply press the arrow, and it should upload it. And you can see down here, it tells you the status, it tells you if there's anything wrong with the upload. That one's done. And then if you look at the TinyDuino that we have set up, it should now have started to blink. Now we want to actually have our accelerometer script. So go onto GitHub and search for my account. So Carlson, Katrina, and then you have to click on Users. And it should just be one of me. So here we go. And now you can click repositories. There's 4 at the minute. It's not that many. And there's a C++ sketch for accelerometers. There we go. And you just press clone or download. Download zip, and you will download a folder with all of the files. The code, go to your download folder, find the correct folder, and copy it. And then we want to put it in the Arduino folder, and where we keep our sketchers. So which on my Mac is on the documents in Arduino. And we just paste the item saying accelerometer master, Tortoise Accelerometer, and if you have a look in there, there's an INO file. So open the Arduino IDE, and the way to upload this now is to press File, Open, and then you simply find that folder. So accelerometer master, Tortoise Accelerometer, and then press that file, open it, and it'll open the whole code file, which looks like this. And you can see at the top we're first loading some H libraries, defining some variables below that, and then after that we have the actual code for setting it up, and then the loop for collecting data. Okay, so we just do this the same way as we did it before. We press the upload button and then we wait. So the benefit of the Arduino environment is that once we've uploaded this, we can remove the USB shield, and the minute we connect power, it just automatically starts running the sketch that we last uploaded. So, when we now look at it, we can see that loads of lights are blinking when it's uploading the sketch. And then if you look at the other side, that little light is now blinking much faster because the recording rate is much quicker. And then finally we put it in a waterproof little box. And then we attach it to our tortoise securely. And then you just bring your tortoise outside, you release it and make it run around and walk around. Finally, when you want to access the data, you just read in the SD card. You get this file called data log, and the top you actually have to set the column name, so X, Y, Z, temperature, and then milliseconds. So we measure milliseconds from starting, so you actually have to convert that if you want actual time and date later on. So you can see here we have temperature, it's very steady the whole time we were out. And we can see there's some variation here in the graph. There's not a lot going on here for a section. And then there's quite messy here in the start, probably because it's shifting between walking or standing still and laying down. And we have some bigger peaks here, which is probably the running sections. And some that are quite steady, but very different in how they look, which should be the walking sections.